Good morning students, how are you? I am Francis sir and today we are going to study Standard 6 Geography. Okay, so this is the third chapter, the motions of the earth, and today we are to study the part 2 of the chapter. Okay, so the part 2 is our revolution. Okay, so today we will be studying revolution. So what is revolution? Revolution is the movement of the earth around the sun. For example, you can see the diagram. This is our earth, and the earth is moving around the sun, which is placed almost at the center. So this movement of the earth is called what? It is called revolution. Okay. So this revolution, it takes the time for the earth to complete one revolution. It takes almost, time taken is almost 365 days. Okay, how many? 365 days, and something about 5 hours and 43 minutes. 5 hours and 43 minutes. Okay, so this is the total time taken for the earth to take revolve around the sun. The earth revolves around the sun in an orbit. What is this part? This part is called orbit. What is this called? Orbit. And this orbit is not circular in shape. This orbit is not circular in shape. It is somewhat elliptical. It is what? Elliptical in shape. Okay, you can see this egg-like shape, no? This egg-like shape of the orbit. It is called elliptical. Okay. So in ellipse, we have a special type of condition that the sun at one point is at the maximum distance from the sun, and at one point the sun is at the minimum distance from the earth. Okay, so the place where it has the maximum distance, at that time, this period is called aphelion. What is called? Aphelion. Okay, and the part of the year in which the earth is closest to the sun, this time is called perihelion. What is called? Perihelion. What it is called? Perihelion. Okay, so that is about the distance of the earth from the sun. Where it is at the farthest point, it is almost 152 million kilometers. Okay, and when it is closest, it is almost 147 million kilometers. Okay, so that is about that. And yes, that is about the revolution of the earth. Now we will see some of the effects. The major effects of revolution is number 1, seasons. What? Seasons. Okay, seasons occur because of the revolution of the earth. If the earth would not have done its revolution, there would not have been any seasons. Okay, so this is the very important part. Okay, now one of the other effects of our revolution is the summer solstice. Summer means solstice actually. Solstice and equinox. Third one is your equinox. Equinox. First one is changing in seasons, then we have solstice, and then we have equinox. This solstice, it is of two types. It is of two types. One is your summer, and another we have winter. And equinox also we have two. One is your spring equinox, and the third one is your autumn. And the second one is your autumn equinox. So basically we have seasons. We have 4 seasons. Then we have solstice, we have 2 solstices, and the equinox, we have 2 equinox, spring equinox and autumn equinox. Okay. So how do these seasons change? How do these seasons change? Seasons change because of the revolution of the earth. Seasons change because of the revolution of the earth, and also because the earth is tilted. Because the earth is tilted. Okay, I will explain it to you after some time. And then one more thing that we have, number 4, that is your varying length of day. Varying length of day. Okay, why do the length of the day varies from time to time in the whole year? That is what we have to see. Okay. So first we will see what is solstice. What is solstice? Solstice is a time period. Solstice is the time period when this sun shines vertically over the tropic. It shines vertically over the tropics. Now we will see that there are 2 tropics. One is your Tropic of Cancer and the other one is your Tropic of Capricorn. You see in this picture, no? This Tropic of Cancer is at the minimum distance. You know, it is the nearest, whereas you can see equator is also this much length ahead, and Tropic of Cancer is also this much distance ahead. So which is the nearest one? It is your Tropic of Cancer. So the sun shines vertically over the Tropic of Cancer. So when the sun shines vertically over the Tropic of Cancer, it is called summer solstice. What it is called? Summer, because you know we generally majority of the people live in the northern hemisphere, and Tropic of Cancer lies in the northern hemisphere. Therefore, it is called as summer solstice. Okay. Now you see this side. Here, this our Tropic of Cancer here. You know, its distance from the sun is minimum, whereas here you see equator is also this much farther, and this Tropic of Cancer is also farther. Both are far away from the Tropic of Cancer. Okay, in turn it is more away from the sun with respect to the Tropic of Cancer. Okay, so this Tropic of Cancer, on this, you know, the sun shines vertically over it. Therefore, it is also called your solstice. But since it is shining over the Tropic of Cancer, and we live in the northern hemisphere, no? We live in the northern hemisphere, above the equator. So it is winter for us. But the sun is shining over the tropic. It is winter for us, and the sun is shining over the tropic. Therefore, it is called winter solstice. Here, the sun is shining over the tropics, but it is summer for us. It is summer for us. Why? Because the sun is shining in the northern hemisphere and over the Tropic of Cancer. Okay, so it is summer as well as solstice. So summer solstice, when we experience summer and the sun is shining over the tropic, it is called summer solstice. And the sun is shining over the tropics and it is winter here, then we call it as winter solstice. So this is your winter solstice. Okay, this summer solstice will happen on 22nd June. Okay, it happens on 22nd June, and winter solstice happens on 22nd December. 22nd December. Okay, so this is your summer solstice, and this is your winter solstice. Okay, after this is done, we will go for equinox. Acha, but one more thing, you might have understood that when it was summer solstice, we were experiencing here what? We were experiencing here summer, and here we are experiencing winter. So you see that there is change in season when the earth revolves from one part of the orbit to the another part of the orbital plane. So there is change in what? Change in seasons. Okay, so change in seasons also occur because of the revolution. Okay. Now we will talk about equinox. For equinox we need to come here. You see, I will try to explain with this portion. Okay, let us consider that this is my hand, it is your sun, and this is your Earth's axis. It is your Earth's axis. Okay, so now what it is doing? It is facing. It is facing what? It is facing the sun. It is facing the sun. And now you see that the back portion is facing the sun. Here the top portion is facing the sun, and here the back portion is facing the sun. That means it is summer in this portion, whereas that this time it is winter in this portion and summer in this portion. Okay, when this starts to rotate in this direction, you see that the portion which was in the front and the portion which is at the back, both are at equal distance from the sun at now. See, first it was like this. This portion is closer and this portion is farther. But now it is like this. Both this portion and this portion are at equal distance from the sun. Since both the northern hemisphere and southern hemisphere are both at equal distances from the sun, therefore, we have equal days. We have this condition, this time we have equal days and night. Equal days and equal nights during this period and also in this period. So if this is the sun, it is here, both are at the same place, and here also, here also both are at equal distances. Both are at equal distance. Northern hemisphere also and the southern hemisphere both are at the equal distances. Therefore, it is called equinox. So here we have 12 hours of day as well as 12 hours of night. Okay, here and this portion. So this is the portion which comes after. This portion comes after. This is winter time and this is your spring time. So spring time it is 21st March is your spring solstice, and then you have 23rd September we have autumn equinox. What do we have? Autumn equinox. Equi means equal. Equal days and night. Equal days and night happen on equinoxes, and this happens when the earth at the time during the 23rd September and 21st of March. 21st of March is called your spring equinox, whereas 23rd of September is called your what? Autumn equinox. So that is about what? Equinox and solstice. Okay. Now we will try to understand. Why the length of the days and night vary. Let us see. Okay. See, this is the sun. So in a way, because of this light, we will have a circle of illumination around somewhere here, around this place. You can see this. I hope this is this side it is day, and this and to the left side it is night, because this side we have sun. So you see that since the earth is tilted in this way, Majority of the earth on the northern hemisphere are facing the sun for a longer time. You see, this is the day and night. This is the day and night portion. So you see only this small portion, only this small portion of the northern hemisphere is having the night portion, whereas the majority of the portion is having the day. So it takes a long time. It takes a long time for a place to move like this and come back to this dark portion, which is the night portion. No? So you see, because of this, because the earth is tilted, we have varying length of day and night. Here it is long days, small nights, whereas here you see this southern hemisphere below the equator. You see that these areas have a very long night and have a very small day. You see, it takes, the day is very short, it rotates and its portion of rotation is over very fast. This portion of rotation is over very fast and it gets to darkness very fast and it comes after the darkness to the light portion after a long time. You see, because it has to travel so much large distance and here so much small. So small distance, so the time passes very easily and very fast and the days become small. And here, since the distance is more to be traveled, so it takes a long time to reach the same place again back to day portion. So we have a larger nights. The same goes here. The same goes off here. Here we can see that this portion, again we will draw this, that circle of illumination of portion. After this, we have day and after this we have night. So you see that this portion in the northern hemisphere, they are facing the sun for a long time and therefore it has long days when it is winter here in the northern hemisphere. And you see that in winter, this northern hemisphere has a large portion of dark side, therefore there are long nights during the winter. Whereas during this 23rd September time and this 21st March time, both the northern and southern hemisphere are at equal distances. Nobody is facing the sun. Both North Pole, for example, if this is the facing, if this is the sun, this North Pole is facing the sun, But during the March time, it is like this. It is not facing the sun. You see that this is the North Pole and this is the South Pole. Both are at equal distance from the sun. Okay. So therefore, we have equal days and equal nights. That means 12 hours of day and 12 hours of night during 21st March and 23rd September. So this was all about revolution. Okay, what is solstice, what is equinox, these are very, very important things. How does the length of the day vary from time to time the whole year? Yes, this is all we studied today. So I want you to revise and try to understand it properly. If you have any doubt, please inform us. Okay, see you in the next video.